everyone, this is Mrs. Pagan, and in today's lesson we're going to be talking about solving systems of nonlinear equations. Now we are used to solving systems of linear equations, but our focus will be on nonlinear equations today. Alright, so first question is, where do you think are the solutions in a system of nonlinear equations? Great job, yes. Solutions in a system of nonlinear equations are at the intersection location. So where we intersect. So solutions, let's write that down, are located at the intersections on the nonlinear graphs. Okay, and so what we want to do is kind of visually show you what this looks like. So when it says what are the number of solutions between a line and a parabola, well, remember that a parabola is a quadratic. Here it is, and here is a line. So there could be a time where the line and the parabola don't intersect, and if that happens, then we can say there are no solutions, because if the solution is where they intersect and they don't, then obviously this does not, so therefore there is no solution. Another case could be if a parabola and a line end up touching only in one spot. Well, in that case, there would only be one solution. You can visually see what that looks like. Now, you can also have another case where the parabola, let's make this one a upside down parabola, and the line intersect at two locations. So the line is kind of cutting through the parabola, and this would have two solutions. All right. So we can now visually see what each one looks like. Let's go a little bit further. How about number of solutions between two parabolas? So what are some of the cases that we could run into with these? Well, you can have a parabola mad at another parabola facing away from each other, and in that case they're not touching, so therefore there's no solution. They want nothing to do with each other. You could have a scenario where the parabola are just only touching in one location. Okay, so in that case we have one solution. And then you can have a parabola almost interlocking with another one, creating two locations of intersection, creating two solutions. So these are some of the visuals that we have for you to just kind of see. Depending on what it looks like, that's how many solutions we're going to be searching for. Alright, let's talk about solving these graphically, and that we can actually utilize our calculators a lot in this lesson, and that's what we plan on doing. So in example 1, it says solve the following system of nonlinear equations graphically. And so what we're going to do is use our graphing calculator. And remember that when we use our graphing calculator, I'll show you, there's a y equals button, and that's what we're going to be using. That means that everything has to be in y equals before we can solve or input into the calculator. So let's go into I'm going to label this the first graph. This is the second one. So let's take the first one, and we're going to go ahead and solve for y. So I'm going to go ahead and subtract x squared and subtract x to the other side of the equation. These cancel. We're left with negative y equals negative x squared minus x minus 1. I always tend to go in order of highest degree to the lowest. And then divided by negative 1 on each term, creating y equals x squared positive x plus 1. So here's our new and transformed first equation. So we're going to put that in there. And then our second one, let's go ahead and grab that one too and simplify that one. So it's x plus y equals 4. We're going to get y by itself. All we have to do is subtract x to the other side. Y equals negative x plus 4. So here's our new and transformed second equation. So now what I'm going to do is grab my calculator. I want you to go to y equals, and I want you to do exactly what I did, and that's input both of our equations into the graphing calculator. Remember that the x button is right underneath the mode, okay? And the square button is right here, diagonal to the number 7. So once you put that in, make sure you do it, please. I'll wait for you. All right, I'm still waiting. You got it? All right, great job. So now let's look at visually how this looks. So let's press graph. So I'm going to go to graph, and visually you can see the graph. You can see a parabola and a line going through it. And visually we can see that there's 2 locations where the answers are meeting. So we have one right there and one right there. So we want to find the intersection point, okay? So we know we have to get 2 solutions because visually you can see them. All right, so here's how we would find or calculate our intersection points. We're going to go to second, trace, and you'll see the word calculate written there. Since we're looking for intersection, we're going to go to number 5. So I like to just press 5 and it'll take me there. And it'll ask me a question like first curve. I like to go closer before I answer any questions, closer to the intersection that I want to find. So here's the intersection I'm trying to find. And then I'm going to go ahead and press enter for the first curve. Notice I was on the parabola. Then it says second curve. Notice that the little blinking thing went on to the line. Press enter again. Do you want me to guess? The calculator's asking, and we want to say, yes, please, enter again. And then the intersection point is given to us at -3, 7. So that would be one of our solutions. All right, I'm going to just go back to my notes really quick. So one of our intersection points is at -3, 7. Now, let's talk about where's the second one. So I'm going to go back to our graphing calculator. I'm going to do the same thing, go to second, trace, and I'm going to go to intersect, press number 5. Now, I'm still at the old intersection point. I already know that's -3, 7. So I'm going to walk myself by pressing to the right button a lot to get closer to the second intersection I see. It's asking me first curve. Sure, yes, I'm the parabola. Now I'm on the line. That's the second curve. And now it's asking me, should I guess? Please guess, enter again. And here's the intersection at 1, 3. So our 2 solutions is going to be -3, 7 and 1, 3 are our solutions. All right. Well done. All right, now let's look at another example. Now, there's also another way we can solve these problems. It's using algebra. And there's 2 ways we can do this. One is using substitution. One is using elimination. We're going to start with substitution here, and then we'll kind of move on from there. Now, when it comes to substitution, what I like to do is try to get one of the variables by itself and input it into the second equation. So what I'm going to do is I'm going to take the second equation they gave me, and I'm going to go ahead and solve that for y because it's just way easier to do that. So I'm going to subtract the 3x to the other side, creating y equals -3x minus 3. This is now my new equation for the second equation that I had. It's the same thing but just transformed. Looks a little different to the eye. Alright, so now I'm going to go ahead and take that equation and I'm going to put it back into the first equation. Instead of writing y, I'm going to put -3x minus 3 plus 5x squared. Notice that there are no more y variables in there, so my goal is to now solve for my x. So I'm going to simplify. 2x minus 3 equals -3x minus 3 plus 5x squared. and I'm going to combine like terms. It is a quadratic, so I know I need to get one of the sides to be by itself, to be equal to 0. I'm going to subtract 2x and add 3. These cancel. I have 0 on the left side of the equation now, and I have negative 5x. Negative 3 plus 3 cancels, and I'm left with plus 5x squared. Now, it is a quadratic. I'm going to go ahead and factor what they have in common, and I see that they have a negative. I'm going to rewrite it so it's 5x squared minus 5x. I notice that they have a 5 in common and an x in common, so I'm going to factor that out, leaving me with x minus 1. And now I have two factors, and I can do zero product property and set each one, 5x equal to 0 and x minus 1 equal to 0, and solve. So x equals 0, because 0 divided by 5 is 0. And here I would get x equals 1. Alright, now, some people are like, woo, we're done. Unfortunately, every x should have a y value because these are points. So what we're going to do is figure out what is, well, when x equals 0, what is y equal to? And I'm going to go ahead and use this equation right here that I have so I can find it. So here's what we're going to do. Well, when x equals 0, I'm just kind of moving it here. I want to know what's y equal to. Well, I'm going to use y plus 3x equals negative 3. This is the second equation that I have right here. And I'm going to go ahead and input. So y plus 3 times x, I know what number it is, 0, equals negative 3. Well, I have y, this is 0, equals negative 3. So therefore, when x is 0, y is negative 3. That is my point. That is the location where the intersection is happening. Notice that it's an x and a y point. Okay, so it's really important that you see that it's a coordinate. Now we're going to do the same thing for x equals 1. So I'm going to just write x equals 1. I want to know what is y equal to. I'm going to use the second equation again, just because it's way easier than the first one. Y is a y, a 3 is a 3, and x, in this case it's a 1, equals negative 3. So I have y plus 3 equals negative 3. When I subtract 3 to the other side, I get y equals negative 6. Alright, here's my point. My second point then is going to be 1 comma negative 6. So here are my solutions. I like to write everything down. 0 comma negative 3 and 1 comma negative 6 are our solutions for this nonlinear system. Alright, so that was substitution. It is wild and crazy. I hope you enjoyed it. There's one more method that we have, but we're going to just kind of, I'm just going to tell you about it. It's elimination, and I'm sure you've heard it before. We're going to cover this in class as soon as you enter. Alright, so great job today. Give yourself an applause. Woo! Way to go. Alright, I can't wait to see you in class. Enjoy the practice problems. Alright, have a good one. Bye.